Once again, ladies and gentlemen, welcome to the HVC movement, Fraser Nation on YouTube. And today we're going to be talking about 2.1, which is using inductive reasoning. You guys have been using inductive reasoning in your mathematics career up to this point. We're just going to formalize some things, kind of get some things set up because we're about to go into proofs in this chapter. So this is basically your first real test in the water, so to speak. In this lesson, students will be able to find patterns and use inductive reasoning. And at the end of this lesson, the question you need to be able to answer is, how do you use inductive reasoning in mathematics? Okay. There's really no material I need you to remember before this. So let's go ahead and go to the next slide. There's really only a few cards for this lesson. So remember, everything you see on this video needs to be in your notes. Okay? There's no half stepping, no step and catch or whatever. I need you to have this material in your notes. Everything that you see on the screen needs to be in your notes. You have the option to pause the video. You have the option to, I don't know, look at the video like 15 times if you want. There's no excuse that you should be missing anything in this video in your notes. So anyway, key vocabulary. You only have 3 that you need to worry about for this section. The first one is a conjecture. A conjecture is an unproven statement that is based on observation. It's basically a guess. Okay, so if I say something like, it was raining Monday, Tuesday, Wednesday, my conjecture would be, well, it's probably going to rain on Thursday. So basically, you look at something, you see something happening, you make a guess. The next key vocab term is inductive reasoning. This is basically a formal definition to the way of finding patterns. Okay? When a pattern is found in specific cases, you write a conjecture for the pattern in general. So when I said that it's raining Monday, Tuesday, and Wednesday, okay, that's 3 specific days, and I write a guess on what's about to happen next. Inductive reasoning is the way of thinking, okay? The third vocab is the counterexample, okay? This is really important. I need you guys to really get familiar with this one. Counterexample is when you basically find an example that will prove your conjecture wrong. Okay. The one thing you need to know about a conjecture is it needs to either always needs to be true. So it's either always true or it's never true. Okay. So when we say counterexample, you only need one case. If one case proves your conjecture wrong, then your conjecture is just all the way wrong, just all the way off, and you need to come up with another one. So let's go with a specific example. So let's see. Let's say something that we're going to observe. Let's say, for example, that it rains every 3rd Wednesday of the month. Okay, so you go back in your calendar, every 3rd Wednesday of the month it was raining sometime during the day. So my conjecture is basically it will rain every 3rd Wednesday in 2016. Okay, a counterexample, I only need one of these 3rd Wednesdays for it to be sunny. So a counterexample would be the 3rd Wednesday in December 2016, it was snowing. Or it will snow. Okay, so here's a counterexample. Okay, it's gonna snow It's not going to rain. So your conjecture turns out to be false. Okay? Because every third Wednesday in 2016 it needs to rain. The counterexample, it's not going to rain in December 2016 for the third Wednesday. So you've proven your conjecture wrong, and you need to come up with a new conjecture. Next card. Okay, the guided practice. Number one. Now, if you don't have your textbook on you, these are basically the 4 circles that they give you in example 1 and 2.1. Okay? And the guided practice is we want to sketch the 5th figure in the pattern. So if you'll notice, here's one circle, the top half is colored. Next circle, this portion is colored, this portion is colored, this portion is colored. So what pattern do you see here? How can I go from a circle with 2 halves to 4 portions, 4 portions to 6 portions, 6 portions to 8 portions? Well, let's go ahead and go above and beyond in this problem. How do I go from 2 to 4? I had to add 2. Okay. How about going from 4 to 6? I had to add 2 new portions. Okay. 6 to 8, the same. I have to add by 2. So here's your pattern right here. You have to add 2 to each successive circle to get to your next figure in your pattern. So if this is 8, this has to be 10. So hopefully we can go ahead and do this. Let's see. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, I know it's a terrible drawing, but there are 10 portions in here. You have to go with me on that. And so, if you'll notice, let's go ahead and throw this circle out. Over here, here's your left radius of your circle, and the portion above it is colored in. Left radius, your portion is colored in. Left radius, your portion is covered in. So right here, here's your left radius, and we're going to color the portion that is right above it. Okay? So, in your notebook, you are coloring in this portion right here. Okay? And the pattern here was +2. Questions? Number 2, describe the pattern in the numbers 5.01, 5.03, 5.0. Should be a 5 right here. Let's go ahead and change that up. Oops. Let's see, eraser, and change this up. This should be a 5. You guys should have stopped me. 5.07. Okay, blase, blase, blase. So the pattern that I see here, let's go ahead and say describe first. Okay, so what's going on with these numbers? Okay, what's going on with these numbers? A good way to find patterns, if you take your first number and either subtract or divide by this number. So if I were to take and say 5.03 minus 5.01, I would get 0.02. Okay? What if I did 5.05 minus 5.03? I would get 0.02. Okay, so what's going on in this pattern? Every number increases by 0.2. So increases by 0.02. Okay, and the next 3 numbers in the pattern, so let's say next 3. The next 3 in the pattern is, well, if you add 0.02 to this number, you're going to get 5.09. Then you add 0.02, so you're going to get 5.11. You're going to add 0.02 again, and you're going to get 5.13. Okay? So a good way to find patterns is if you take this number and subtract, take this number, subtract, take this number, subtract, or take this number, divide, take this number, divide, take this number, divide. That's a good way to find patterns if it doesn't just jump out at you. Next card. Okay, I didn't really finish this one. So let's say, suppose you're given 7 collinear points. Make a conjecture about the number of ways to connect different pairs of points. So here's a chart that they give you in your book. 1 point, 2 point, 3 point, 4 point, 5 point. So this is basically a chart of collinear points and the number of ways you can connect them. So right here, number 1, can't really make a connection between 2 points because you don't even have 2 points. Okay. When you have 2 points, you can only make 1 connection. When you have 3, here's 1 connection, here's 2 connections, here's 3 connections. Next, if you have 4, 1 connection, 2 connection, 3 connection, 4 connection, 5 connections, 6 connections. Okay, so a pattern that really should be jumping out at you is, well, number of connections. Add 1, add 2, add 3. So what's the next pattern going to be? Well, let's say add 4. So if we add 4 to 6, this number should be 10. Okay, so if you were to go through and count each one of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you'll find 10 connections. So as you can see, my handwriting is a little messy, so I'm not going to attempt to try to draw these pictures, okay? But we have the pattern, so we could probably go ahead and figure this pattern out. So let's go ahead and make your chart. If you have 6 points, okay, and let's say pick right here, then what are you going to do? What's your next pattern going to be? Well, if it was 1, 2, 3, 4, we're going to add 5 to this one. So right here is going to be 15. If you do it again, then what does this have to be? Well, it has to be plus 6. So if there are 7 points, okay, and you were to draw the picture out, you can actually do it 21 times, which I'm not going to do here. Or you can take 15, add 6, and there should be 21 unique connection between pairs of points. So let's say 21 connections. Okay. So yes, in your notes, this chart needs to be in your notes. Number 4, make and test a conjecture about the sign of the product of any 3 negative numbers. So I need to take 3 negative numbers, multiply them together. Is it going to be positive or negative? Okay. So how I would do it, I would just pick any 3 negative numbers. Let's say -1 times -2 times -3. Well, what happens anytime you have 2 negative numbers? They're going to become positive. So this is 2 times -3, which is -6. Okay, let's try it again. -2 times -3 times -4. I think you guys know where this is going. So negative times negative is a positive, so positive 6 times -4. So we have -24. And you guys are welcome to just go ahead and keep testing this out. But a conjecture for me would be the sign is always going to be negative at the end, because your first 2 calculations are always going to be negative. So whenever you multiply a positive number and a negative number, you will always get a negative number. So my conjecture is going to be always negative. Always negative. Okay? Because like I said, anytime you multiply a positive number, which you will get the first two times, the first two numbers that you multiply, it will always be a negative number. So here's my conjecture, here's my test, and you can go ahead and just keep testing it out. Next card. Number 5, find a counterexample to show the following conjecture is false. The value of, and that should be an x squared, so let's go ahead and change that now. Okay, so the value of x squared is always greater than the value of x. So let's say 2 squared, okay? That's going to be 4. Okay, so if I had x squared, then my x is always the base. So basically what this saying is when you square the base, the answer is always going to be bigger than the base. So 2 squared, 4. What about 12 squared? 12 squared, 144. Okay. What about 21 squared? So let's say 21 squared, you get 441. 441 is bigger than the base, 144 bigger than the base, 4 bigger than the base. So the conjecture appears to always be true, but I need to find one counterexample. I need one case where that's not true. And basically, when you put a fraction in, if your base is a fraction, then your answer is going to be smaller than your actual base. So, for example, if you have 1/2 squared, that's going to be equal to 1 squared over 2 squared, which is equal to 1/4. Okay? So if you type this in the calculator, your base is 0.5. Okay? So you get 50 cents. Over here, we did our calculations, and our answer, if you plug this in the calculator, is going to be 0.25. And I don't know where you came from, but 25 cents is always smaller than 50 cents in my world. So here's your case. My conjecture is busted. Last but not least, number 6, use the graph to make a conjecture that could be true and give an explanation that supports your reason. So when I look at this table right here from 1990, 1995, 1995, 96, 97, 98, 99, 2000, blah, 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 I'm going to say that my conjecture is that participation will increase. Okay? Look at your chart. Okay? It has increased every year. So my reasoning is going to be because, so reasoning, participation has increased the past decade. Okay, so if it's increased the past decade, then there's no reason to think that participation is going to drop. Okay, your homework will be uploaded to Schoology. Give it a try. I'll give you guys a worksheet, and hopefully you come in Monday with questions about your homework. Until next time, Fraser Nation, out.